All right. Good day, everybody. My name is Lillian Gosspers, and I am the project manager for Elk Construction Consultants. And today we will be going over our final presentation for the Amazon Industrial Site project. It worked 2 seconds ago. Cool. Anyway. Cool. Anyway, with me today, well, as I said, I am the project manager for Elk Construction Consultants. And with me today, I have Elizabeth Walker, who is our Environmental Engineer 1, and I have Caitlin Frank with me, who is also our Environmental Engineer 2, and I am also the Transportation Lead for this project. So I'm just going to go over the project overall for a little bit. So what I was in charge of was the design of a new connector road between County Road 19 and the toll road entrance, and the design of access to and parking lots for any facilities on the site. In addition, our team was tasked with the design of stormwater BMPs to control runoff volumes and improve water quality, and the design of a wastewater treatment facility to treat 1 million gallons per day, as well as a drinking water facility to treat the same flow rate. We also had to do the determination and design of any necessary fire protection for the site, and the environmental scopes were also said to have designed for high efficiency using the latest technologies, and all designs were meant to follow all applicable local, state, and federal standard codes and regulations. This is just a site overview. You can see there's the project boundaries, which are in the red dots, as you can tell. It also looks a little orange, so let's go with orange. As well, we have the green is the roadway alignment, as well as the blue dashes are the vegetated swales and other stormwater management practices. In addition, you can see there are the 2 fire hydrants, which are those red circles, and as well the pink line is the piping that will connect the drinking water facility to those fire protection. All right, I will start on my transportation work for you guys today. So this is the design alignment that I went with. We've talked about it before. This is just an east-west bisector, you can see here. As well, you can see the parking lot on the site, which will be for a future warehouse facility that is not in design at this time. For this design, because of the road is 45-mile-per-hour road, the minimum curve radius is 645 feet, and there are 2 horizontal curves on this alignment with the minimum tangent distance in between. As well, you can see on the westernmost part of the site there is a signalized intersection, and on the easternmost site there is a stop-controlled intersection. This is the design criteria we use. It is primarily from the Indiana Design Manual with some additional design criteria from the AASHTO Green Book, as well as Elkhart County Codes and Ordinances. We've kind of gone over this before, so I can answer any specific questions later, but that's just what we've seen. This is the typical cross-section for the road. This is the 2-lane road going either way. The only thing really of note that you may not have noticed previously is that the top course is a concrete course, whereas most roads in the area are also asphalt. However, this was chosen because the toll road entrance, which is where most of the trucks may be coming from for the traffic, is also a concrete course. This is another typical section, the only other real one for the site. This is because there is a turn lane section in the intersection, and this just includes the other extra lane that is used for the turning movements. So this is just the intersection details for the new connector with the toll road entrance. Of note is that there is the turning radius of 125 feet at all corners to account for that 45-mile-per-hour speed on this road. In addition, you can see the taper length, the deceleration length, and the storage lengths for each of the turning movements. This intersection is as scoped in the design statement, which was how the lane movements would be picked. And here you can see the new connector intersection with County Road 19, which is a stop-controlled intersection. However, the only thing that is designed here is the actual new connector, because the County Road 19 details are out of scope. Here's also a sketch of the parking lot for the future structural facility. This has more than the required 58 parking spaces, and it does have 3 accessible spaces and 1 accessible van space. In addition, there are truck bays in the back. However, with the unknowns about this facility, we're not sure if those will be included in the actual work, or construction work. As well, there's a construction maintenance of traffic. Due to how this road is aligned, we are not actually having to realign the toll road entrance, so the maintenance of traffic only includes a movement of moving 1 lane over and closing those lanes to construct, and then switching to the other half of the road as well, just because there's not really a huge concern about closing down the road completely because it's not being completely realigned. And as for the cost for the construction, this is the final construction cost estimate. Things of note, the total construction cost with contingency, 20% contingency is about 5.1 million. However, you may note that some of the prices made are underestimate. This was using the INDOT unit price spreadsheets. One thing I will note is the biggest costs on this are the cut and fill costs. However, those were using the costs for trucking in and trucking out the cut and fill. So this would likely be less, as the cut and fill is generally even across the site, so it would not really need to be trucked in or trucked out for any dirt. And with that, I will hand it off to Elizabeth Walker for Environmental 1.
Thank you, Lily. Like she said, my name is Elizabeth Walker. I'm the Environmental 1 engineer for Elk Construction Consultants. So in my scope was to design a wastewater treatment facility to treat 1 million gallons of water per day. Here's just an overview of my treatment train. We have our primary treatment, or pre-treatment, primary treatment, and then secondary treatment. The first item is the partial flume with a peak flow of 0.11 meters cubed per second. The throat width is 0.23 meters and the depth is 0.15 meters, and within our regulations it had to be less than 2 meters, which it is. And we're going to also add 0.6 meters of freeboard for a total depth of 0.75 meters. Next up is the bar rack channel with a depth of 0.18 meters. We're also going to be adding that freeboard to this. The area flow is 0.1 square meters, and the velocity of the water is 0.43 meters per second. Within this channel is going to be our bar racks and screens. So for our bar racks, we're going to have 16 bars with an effectively open area of 0.26 square meters, and the velocity going through those bars is 0.42 meters per second. For our fine screens, we're going to be working with 1 millimeter openings and an effective open area of 0.469 square meters. Next up is the grid chamber with a width and depth of 2 and 2.5 meters, and the length is 10.5 meters. We want this to be a little bit longer because we have such a low flow rate. The water has to stay in there for a bit longer in order to allow everything to settle out. The velocity across the bottom is 0.2 meters per second, and that has to be at 0.2 meters per second or less, so we're making sure that the grit doesn't get picked back up and remixed in with the water after it's settled out. The volume of grit to be removed is 1.9 cubic meters every day. The primary and secondary clarifier, an important note to make here is that I'm working under the assumption that the dimensions will be the same for the primary and secondary clarifier, with a diameter of 13 meters and a depth of 5 meters. The feed well in the center is going to have a diameter of 0.6 meters and a depth of 3.44 meters. The velocity is limited to 0.02 meters per second. We want to make sure it's not going too fast, so it's not flying up out, shooting up into the air. And the velocity across the sludge zone is 0.01 meters per minute. The activated sludge system, so the BOD5 effluent is limited to 25 milligrams per liter per month, and the total suspended solids are limited to 30 milligrams per liter per month. And we're going to be working with a hydraulic detention time of 5.1 hours. The dimensions of the aeration tank are 33 by 11 by 5.5, and we're going to have an oxygen demand of 220 kilograms per day, so we're going to be using 23 aerators to achieve that. So this is the final construction cost estimate. These are quite rough numbers. These treatment items aren't really something that can be commercially just like bought at their sizes. Everything is individually sized. So I did a lot of research from a lot of different websites and was able to find kind of a general estimation, and coming up to about $20 million. And with that, I will hand it over to Caitlin.
Hello everyone, as Elizabeth had introduced me, I'm Caitlin Frank. I'm the Environmental 2 engineer, a part of Elk Construction Consultants on this project. I was tasked with the design of a drinking water treatment facility in order to treat 1 million gallons of water per day, as well as all on-site fire protection. Moving into the design. Here's the drinking water treatment train facility layout. starting with the wells, distributing the water to be treated through each different treatment unit, to water storage, and then final distribution where it will get distributed to all on-site fire protection. Moving further into the design process, we will start by talking about the submerged pump and well design. So the water source of this system will be gaining water from the St. Joseph Aquifer. We will use a submerged vertical turbine pump as our intake structure, which will include a well screen in order to filter out any solids being retained. The estimated static water level of this aquifer is 25 feet, and we will be adding an extra 60 feet of depth to this well in order to account for any drawdown or allowable withdrawal requirements. And this will be designed for a flow rate of 700 gallons per minute. More added to the well design, we will be using gravel-packed wells for this system. The system will include 3 wells in order to meet all demand and redundancy requirements. For the redundancy requirement, 2 wells are expected to run at the same time while 1 sits on standby. This is standard for all treatment units within this treatment train. And in order to make sure that all units are being used, we are going to put them all on a rotational schedule to make sure that none are sitting and just not being used. The flow type of the system is parallel in order to provide consistent water flow, and then the wells are required to be spaced 75 meters apart. Moving into the first stage of treatment, this is the pre-oxidation stage. This is the initial chlorination of the water. There will be 2 of these units provided, and each unit will have a design volume capacity of 32,387 gallons. The disinfectant used during this stage will be 12.5% sodium hypochlorite, which will be dispersed at a feed rate of 144 milligrams per milliliter, which is the typical rate of dispersion. Moving into sedimentation, there will be 2 of these units included within the facility, and each one is designed for a design volume capacity of 175,974 gallons. Next is the rapid sand filter. This is for filtration of the water. There will be 4 of these units provided based on redundancy requirements. 3 are set to run at the same time while 1 sits on standby. So per 3 units, the design volume capacity is 132,086 gallons. There are multiple different steps in this filtration unit, including the design of the wash water trough, as well as the sand and gravel filtration layers into the under drainage system before it can be dispersed to the next treatment stage. And further design of this process is shown in these 2 schematics, the design of the filtration layers as well as the under drainage system for this process. Moving on to the next treatment stage, we have lime soda softening. There will be 3 of these units provided. 2 are expected to run while 1 is sitting on standby. Per 2 units, the design volume capacity is 85,063 gallons, and this is to treat the water hardness levels of the water from the aquifer, which is 279.5 milligrams per liter. As the water from this aquifer contains both carbonate and non-carbonate hardness, we have to treat it with both lime and soda ash. Moving on to the disinfection unit, there will be 2 of these units provided. The disinfectant, this is the final chlorination of the water in the system before it can be dispersed to storage and then distribution. The disinfectant used will be 12.5% sodium hypochlorite, given at a feed rate of 2,271 pounds per day in order to meet the target residual range of 0.5 to 5 milligrams per liter. The tanks that will supply the chemicals, that will store the chemicals, are going to be fiberglass double wall tanks. We need 1 tank in order to hold the volume capacity of a daily supply, and then another tank in order to hold a 2-week supply. So the daily supply tank will be designed for 600 gallons, while the 2-week supply tank will be designed for 6,000 gallons. Moving into water storage, this has been talked about before. This design has been set, but there will be 3 tanks provided with a total tank capacity of 793,149 gallons. Moving into the distribution system and pumping, the system type will follow a tree main system, so it's going to be a water main. The piping material for this water main will be ductile iron with a diameter of 16 inches, and the required pipe length in order for the water to travel from the initial facility all the way to both hydrants is roughly 3,000 feet. We will design with a flow velocity of 1.5 meters per second in order to meet fire flow, residual pressure requirements, and then we will be using a vertical turbine pump to provide 90 to 95% efficiency for distribution. Lastly, fire protection. The fire protection chosen for this project was the East Jordan Ironworks 5 BR250 fire hydrant based on Elkhart County details and regulations and codes. We will provide 2 hydrants on site which were depicted in the initial site overview plan in order to meet the fire flow requirement of 500 gallons per minute and the residual pressure requirement of 20 psi. The connection type of this distribution system to the water main will be a T-pipe fitting. And then for the final environmental 2 construction cost estimate, I made sure to use RS means as well as typical EPA values for some of the disinfection units that were not included in RS means. That combined with inflation costs comes out to a total cost of roughly $7,700,000. And I will hand things back over to Lily for a final project cost.
Thank you, Caitlin. So as Caitlin said, I'm going to be talking about the final project cost. You can see here we have the design cost, the transportation cost, the environmental 1 cost, and the environmental 2 cost, which we have talked about previously. With that and the 20% contingency, we have about a $38.6 million project. In addition, you may notice that we will have our water resources costs at a later date. Do you have any questions? Thank you very much for being here today, by the way.
Thank you. Okay, sorry, who's? This is somebody. Okay. Why did you decide to use concrete versus asphalt for the pavement?
Why did I?
Yeah.
Particularly for 2 reasons. One, because I wanted to ease the transition between the toll road entrance and the project site, because at that time we were looking at a lot of truck traffic will be going to the warehouse facility, and as well as to make sure that bearing capacity is pretty well for the trucks.
Do you have knowledge of the type of soil you have on the site?
I do not know.
I'll just give you this, like expensive soil, you cannot use concrete. Well, that's what happened to us on Indiana 49. You're going to have like that noisy traffic type of thing in there.
There is a pretty good subbase and base course on the design as well. So.
Yeah, if it's more of like the clayey, expensive type of soil, concrete is out of the picture in there. Do you need to acquire land? Because I saw your alignment is different than sort of what's existing.
Yeah.
From the aerial image.
I'm gonna get there, sorry. Yeah, so for the most part, this land is available to be acquired. This, here, I'll go over here so you can see this. This section is private property. This section right here is toll road entrance, so I believe we'd be able to work with the toll road to acquire that land. And the rest of it would be able to be bought by whoever is designing the warehouse, so.
Did you include that in your cost estimate?
I believe so, but I'm not entirely sure at this time. The detailed cost breakdown is also in report 3, so.
Okay. So, get to Elizabeth, I'll go in order in here. Thank you for your answer. So, you are designing the 2 tanks, the primary seedling and secondary seedling, to be the same dimensions. Can you tell me what method or methods did you use for designing the primary versus a secondary tank?
So the method that I used was for the settling of it. Oh, there's an equation with 2 different settling methods. Newton's method, I believe.
What type of settling do you have in the primary?
I'm not aware at this
How
time.
about the secondary?
I
What
was
type of settling?
working under the assumption that they were the same.
Let's go back to, for your activated sludge, let's skip that, go to the activated. So you mentioned the hydraulic detention time to be 5.1 hours. About the cell residence time, biomass residence time.
The cell residence time, I believe, was, it was like 10.7 hours, I believe, 4 days.
Which one?
Hours. I'm going with hours. Days.
You're going to be in days.
For days.
So, okay. And did you calculate that?
I did calculate that. Yeah, those are those numbers are all in my calculations in the report.
Okay. So, Caitlin, again, I'll give you the difficulty questions. And
Okay.
start with the one. So you mentioned you're going to have pre-oxidation.
Yes.
Why?
The pre-oxidation is basically just to chlorinate the water, since it is groundwater, so it's the initial chlorination before it goes through the system. I looked up typical treatment trains of what you would put together for a groundwater treatment train, and they always start with some sort of chlorination, which is why I decided to include it in my design.
Okay, you answer my question, why?
I based my design off of the typical treatment train that does treatment for groundwater, which is why I included it in my
So
design.
why do we do pre-oxidation?
For chlorination?
Why? To get rid of the
Because of the
minerals.
minerals
It's
in the groundwater.
Exactly. Yeah, you want to get rid of the minerals, it's not for disinfection.
Yes.
That's not, okay. So you talked about like the softening and the hardness, and you're going from, you're treating for 279.5
Yes.
milligrams to what level?
What do you mean to what level?
So you're gonna, practically you, I'm assuming you mean 279 is high.
Yes, so
You're gonna
anything over 100 milligrams per liter is high. So the carbonate hardness specifically is based on the alkalinity. The alkalinity levels of this water are 245 milligrams per liter. So the remaining of the total water hardness minus that carbonate is the additional non-carbonate hardness. We need to treat for both in order to get the water down to the correct pH for drinking so that it's potable. I have this more detailed explanation in my report 3.
Make it short for me, so what will be the hardness after treatment?
I cannot remember off the top of my head at this time, but it is detailed in report 3.
Okay, so for your distribution system, so you talked about residual pressure in the system,
Yes.
and what would be that?
The residual pressure based on the pipe size and pipe material with its roughness coefficients is 20 psi.
Can we go back to the parking lot?
Yep, I suppose.
This is probably an easy, you guys didn't see it. In the plan view of the parking lot, you were talking about accessible parking spaces.
Yes.
3 accessible spaces with 1 being abandoned space.
Yeah.
So are those
The blue space is right near the building entrance. It's really hard to see on there
yeah, I'm
compared to
looking over-
that.
All right, so point to them for me.
Right here.
Okay, I see, I didn't see that at all. I was looking
Yeah.
at those things on the other side.
No,
thinking,
those over there are the truck bays, the truck
okay.
loading bays and as well
I
as
was
the.
counting way more than 3.
Yeah, that's fair.
Okay, I got it.
Cool.
Thank you.
So I had a question about that slide. Can I jump in? So, did you use some kind of code or something to come up with the number of?
Yeah,
Because it seems low to me, especially there's one band space.
so the Elkhart County regulations specifies a certain number for how many people would be in the building. Our
Yeah.
warehouse facility was not, that we were given in a previous phase of this, but by chance, had a very low like actual occupancy rate, and it was gonna be mostly storage. So that's why our numbers are pretty low, and then there's a certain percentage of that numbers could translate over to the accessible spaces.
Yeah, okay,
So yeah,
thanks.
Elkhart County codes.
And what is that number, what the code, what does it say, how many parking spaces per, let's say, surface area or employees?
I don't remember the exact calculation rate at this time, but it is also in report 3. It's been in every single report since last semester. I can't remember what, it's like a formula, so something.
But it's based on the building type, and for that type, it's low.
Yeah,
Yeah.
building type and like occupancy, expected
Yeah,
occupancy of like
And then
number.
accessible spaces is like 2%. or
Yeah,
something.
and it was, I think it was technically, it was 2 accessible spaces, but I went with 3 to also just be able to include enough to feel comfortable with those numbers. Because it's minimum, not maximum.
And that, as the truck comes in,
Yes.
I see that nice big radius
Mm-hmm.
coming off the road. I don't see a nice big radius getting around that end car in the parking lot.
Yeah, well, that was partially due to the fact that my technical advisor asked for more spaces. That's like, I originally had just around the required number of spaces, and then he asked me to include more because there was a lot of space in my parking lot. So, yeah.
You probably assume that that parking lot most of the time is empty, so.
Yeah, it's not particularly going to be used. It's also not going to be filled to capacity, I anticipate, at any time, because there are not that many workers in this building.
But an easier solution would just move that entrance up so it doesn't interfere with the parking lot.
Yes, that could have been done. It was not done.
Let me make a comment. Usually every ordinance have a minimum and maximum. There is just to make sure when you are calculating the number of parking spaces, they give you the minimum required,
Yes.
but they also want to make sure that people do not exceed. In other words, it's for like a stormwater
Yeah.
management type of purposes, impervious surfaces. They specify maximum number. They give you that like degrees of freedom.
I
No
don't
less than a
believe-
minimum, but no more than the max.
I don't believe the Elkhart County codes had a maximum for a warehouse facility.
I have a question regarding the fact that that line, that exit is going to be used by like trucks or
Yes.
entrance actually. Do you think we need some kind of exit line when we are approaching the entrance from the
An
road?
exit lane. Well,
Yeah.
considering that this connector road is specifically at this time really only going to be used by the warehouse, it wasn't anticipated to need an exit
Okay,
auxiliary
only
lane
by
there.
I have another question, not about this slide.
I can go really in-depth with parking lot, but
Your drainage swales on your road cross-section had a bottom width of 1.2 feet. Did you design that, or did the water resources person design that, or is that just standard?
that was based on a typical section that is usually used for a two-lane road with the design criteria from the Green Book, Bachelor Green Book.
Have you communicated with the water resources person about like the capacity and what their design might be for that? Okay. Okay. Thanks.